All right, everyone, welcome. It's 2 p.m. time in Helsinki. Um, Good afternoon, everyone, and warmly welcome to the KvarkenSat Innovation Challenge in Sustainable Forestry. I'm Ella Ronkainen from UltraHack, leading the project team from our side. I'm here today with my colleagues Franziska Gans and Aleksi Leskinen. First of all, I want to say that this project could not be possible without our amazing sponsors and partners. Thank you for making this innovation challenge possible. I'll give now to the stage to my colleague Franziska.
Hey, thanks Hella for starting this amazing day ahead, and welcome everyone. You are pretty lucky to be here, just for the notice. We have an amazing board of speakers, and the agenda for today, we started 2, as Ella said, and we have a couple opening words. Then we're gonna move on with 80, and we're gonna have a Kvarken Space Economic Project introduction. And for 2:10 until 2:40, we're gonna have the presentation of the team number 1. From 2:40 to 3:10, we have the team number 2, and from 3:10 to 3:40, we have the team number 3. The last team starts at 3:40 and goes up till 4:10, and it's the team number 4. And in the end, we have for all the participants really important information about the platform introduction and really valuable information, so don't miss this spot over there. Last but not least, our closing words again. Starting from 4:30 till 4:40. But before we move into this webinar, I just want to give a quick timeline about the hackathon for those that don't know. So on 10th of March, the deadline registration for this challenge closed. So make sure that you pay attention to this webinar, and then you have the chance to register until 10th of March. On 14th of March, we have a participant briefing for the teams and participants that are selected that we will onboard. And on 15th of March, we have the Meet the Mentor that you briefly introduce your solution and you get the first impression and comments from the mentors. And the big days, the hackathon itself, starting from 18 to 20 of March. Pretty exciting times. In case that you are wondering, okay, I don't have a team, I don't know what I'm doing here, what is this webinar about? I just want to tell you one thing. You don't need to have a team yet. That's why you are here, and you can find a dream team. And me and Ella, we did this like solution, kind of fragrance, how to find a dream team into a couple steps. So register to event. You can check out other introductions and submissions. You can contact interesting persons and teams and join them, and we will also help you with that. So don't worry, we also have this thing that we call matchmaking. It's not Tinder matchmaking, though, please don't confuse, but it's some sort of matchmaking that we do with the teams and participants. And then the next steps, team selection, and probably, and I'm like thumbs up and fingers crossed that you'll be selected to this amazing hackathon. And one thing, ingredients of a winning team. Start searching for the teams early. If you get interested about this hackathon, I'm pretty sure you will. Please join our Slack that we will be sending here, and try to find a team that has the same views and you have complementary skills. You don't need to have like the same ones, and different perspectives, different points of view. So this was like me for now. And now I will give the word to 80. And thank you so much.
Thank you, Franziska. Should I grab the screen?
Yes, you can grab the screen. I can stop mine.
Yeah. So, hello everyone, and welcome to this pre-hack webinar also on my behalf. My name is Heidi Kuusniemi, and I will be presenting to you the project behind this hackathon. I'm a professor and director of digital economy at the University of Vaasa, and I'm also leading the project behind this hackathon, the EU Interreg Botnia Atlantica project, Kvarken Space Economy. I will briefly introduce the goals of this project and how sustainable forestry and satellite data is relevant to our efforts. So this project of ours, where we are building a Kvarken space center, is focused around the region called Kvarken, Merenkurkku, here between Finland and Sweden. We want to promote satellite technology, satellite data, and satellite-based applications in various forms and highlight their essential role in the digital infrastructure of today, with a special focus on this Kvarken region here in the Nordics. We want to foster long-term space-based data utilization, especially in the Kvarken area. We want to develop local expertise and cooperation networks locally and internationally. We want to provide initial and long-term industry support, and then we also want to demonstrate the capabilities of satellite data, satellite technology. This hackathon of ours is a perfect activity in this project of ours, where we have Finnish, Swedish, and also international participation around satellite data usage for the benefit of more sustainable forestry. And the KvarkenSat name in the hackathon name is one of our demonstration missions of this project of ours. Here you can see the KvarkenSat cube satellite, which has Earth observation, navigation, and space sustainability payloads. It will be an interesting multidisciplinary satellite mission, a Swedish-Finnish satellite mission planned to be launched in 1 year. And this is the inspiration for also this hackathon that we are focusing on now. The hackathon, KvarkenSat Innovation Challenge 2022 on sustainable forestry, is about space-based data helping to combat climate change in the forestry and forestry operation context. So possibilities and developments of space-based data. And as said, the hackathon dates are 18 to 20 of March. We have 4 themes, and you can see all of our partners in this Swedish-Finnish hackathon. We are very happy to have such a powerful group of stakeholders here, and then of course you, the participants, joining this hackathon and making something amazing from satellite data for the benefit of more sustainable forestry. Now you will hear more about these 4 themes in the hackathon. I will give the floor to the first theme, the need for more timely estimation of soil moisture, and the floor will go to Anneli Ågren from SLU University in Sweden. Anneli.
Thank you very much. I'm gonna present this way instead, so I get the full screen. Sorry about that. There we go. Yes. Come here. There we go. Yeah, I'm gonna present theme 1. Start doing that, the need for more timely estimation of soil moisture. So the aim of this theme is really to develop tools that can help us protect soils and surface water during different forest management operations. And we want to combine the use of different sensors, from satellites to airplanes to 3D models of the landscape, hydrological modeling, etc. Everything that we can use today and in the future in order to protect soils and surface water during operations. Because a big problem with driving with big heavy machinery on wet and moist soils is that these soils are soft, so the machinery will sink down and lead to these unwanted track formations. This will not only give badwill to the forest companies, it also increases the leakage of nutrients and mercury to the Baltic Sea region, and that's something that we don't want. So we want to avoid this kind of disturbance of the soil during forestry operations. There are of course also ways to protect the soils during operations, for example, building different bridges, using logging mats or slash mats when you drive on the branches and tips of the trees, so you can protect the soil. But the key question is where and when can we drive with the machinery on the forest soils? And in this theme, we really focus on the fine resolution on a very high spatial scale. So it's with instant trafficability. Where do we have drier soils with good bearing capacity? Where can we put the more heavyweight machinery? And where are the soil wet and soft? And where can we put the more lightweight machinery? And perhaps do we need to protect the soils with slash mats? And how can we make a better planning so we can avoid these ruts? For example, reaching in for the trees in the wet areas and lifting them up towards drier soil, etc. And to make a good planning, it's good to have good maps in the background. And as I said, we are focusing on a forest stand level. A forest stand is an area with uniform forest, delineated by these white borders on this map to the left. So, but even if the forest is uniform, we can have very different soil moisture within the stand. But we now have new and improved maps as of a few years ago that can help make us develop better planning tools. So we can avoid ruts like this in close connection with stream networks. So the idea is that with better maps, in Finland we have depth of water maps, and in Sweden we have something called the SLU soil moisture map. We can then delineate the wet and moist areas and avoid driving in these areas, or protect the soils when we drive in these areas. And both of these maps can be used to model different paths for the roads and on-site driving, both the depth of water maps on the left and the SLU soil moisture map to the right. A very short background about these maps. Depth of water maps are constructed by modeling a groundwater level continuously in the landscape. And then where this groundwater level is close to the soil surface, those soils are estimated to be wet or moist, and those are marked with these blue areas on the map. The SLU soil moisture map was generated by combining the information in 28 different maps, including 7 different depth of water maps with different thresholds. And then we used an AI model, which we trained using field data from 20,000 field observation of soil moisture. And that allowed us to model soil moisture continuously all over Sweden at a very high spatial resolution. It's 2 by 2 meter. And if you look at the quality of this map, kappa is a measure of the quality of the map. A perfect map would have a kappa of 1. And we see that depth of water maps have a kappa of 0.56 and the SLU soil moisture map of 0.69, so slightly better. But for riparian zones near streams and surface water, the depth of water maps are also good. And both of these maps are available as open data. So in this theme, we focus on a very high spatial resolution, down to 1 meter or 1 to 2 meter, because that's kind of the spatial resolution we want to work in. Should we drive here or 2-3 meters to the side? It's really about this fine. But even though we have a very fine resolution spatially with these maps, they are static. They don't change with the season. And we have a lot of seasonal variability also that changes with the weather. And Aura Salmibara from Luke will continue to tell you a bit more about temporal variability.
Thank you, Anneli. Yes, I'm I'm Aura Salmivaara from Luke, and I will now continue with sharing my screen. I hope you see it now. So, like Anneli said, that the detailed maps that we have are static in nature, and we would need to tackle this temporal aspect. And I will now show you three different options what there are to tackle this dynamics, temporal dynamics. And first, all of these models are based on this considering the hydrological cycle, which is now here simply put that it's kind of has the evaporation, condensation, precipitation, and percolation, and surface runoff and groundwater flow components, and also the vegetation that the transpiration component comes from that, and then there are also storages of water in the seas and lakes and snow and glaciers, and it's complex. We always when you do some hydrological modeling, you need to simplify a lot, but it's you can do that, and you can have a like very detailed time series of, for example, runoff, and then you model the hydrological basin area, the area that kind of collects the surface water to an outlet, and then you can build your model and compare that to the measured runoff, and then you can have a good hydrological model to see how the water is moving. But now we have made, for example, to tackle this problem, we have made this kind of a spatial hydrological model on a 60-meter grid. But the problem here is that even though we have made this hydrological model, and it has been calibrated and validated with several catchments, that we have some runoff data, we still we don't have that kind of ground truthing data to everywhere, and also the coverage issue is a problem here, that we can run up to 1,000 hectare base watershed areas with this model like easily, but then kind of the computing power comes into its limits, although it's improving, and also there are also hydrological models that can operate on larger coverage, and I will show two of them next. But I think there is an opportunity there to improve. So one problem here is that we are lacking the ground truthing data, and then also we still are on the bit far side of the kind of the spatial detail that we want. But here you can see a kind of a conceptual that it has the vegetation, and it has sort of a buckets of 16 times 16 meter where the water comes in and goes out, and then also is moved within the grid cells through this kind of a one sort of a topographic wetness index, even though there are not kind of intergrid interactions considered, because that would make then the model even more computationally demanding. The other examples I have from hydrological modeling are this SMHI beta version, which is also available to look at on daily time step, and it's a larger extent. It's from Sweden, and but the grid size here is about 9 kilometers, and then there is another harvester seasons also based on hydrological model and some satellite data, but it's also on very high or on a coarse scale, so the grid size is maybe 2.5 kilometers. So when we get the coverage right, so we get a very large area and we get daily time step, but then we lack the spatial resolution. So I will end here, and just to show on this diagram that where we are now, and then Kendall will talk more next on the satellite data.
Okay. Aura, thank you. Now you can see my screen.
Yes.
Yes. And this is in the way here. All right. I will briefly discuss some of the available satellite observations and derived data initially, and then discuss soil moisture that is can be taken from the EU's climate change program. Okay. So these sensors along the side that are listed, these are in operation now, and you see some of the details about the spatial and temporal resolution. We benefit in our northern latitude. Our temporal resolution for the passing of these satellites is effectively improved. It's worse at the equator. These to go into these separately maybe is not possible now, but one common mechanism that's going on is that these satellites are measuring the effects of the dielectric properties that they're sensing. So what does this mean? So there's a basic physical quantity, these dielectric properties, and basically as the amount of water and some of the observed materials at the surface, as the amount of water changes, these dielectric properties change. And what that means is that the way that electromagnetic radiation is emitted from these properties and the way it can be received by these properties is different, and it changes as a function of the water content. So you can have a radar type of instruments. We say active instruments, and these are the center two here, SMAP and ASCAT. These are effectively sending electromagnetic radiation like a radar to these to the surface, and then receiving the return backscatter, and then working to calibrate that to soil moisture quantities. And the other two, the SMOS and the MSRE, these are passive types of instruments. Okay. Here are two examples trying to show some of the issues. On the right-hand side is the passive instrument, the SMOS, and it is, you can see that there's an issue sometimes with the entire spatial coverage. So this is the nature of the results that you get with some of the passive instruments. On the left-hand side, this is SMAP. So this is actually both an active and a passive type of instrument. It's two in one. So they combine this information. So you can get better coverage, but indeed, excuse me, you can get better spatial coverage. But indeed, to get to get this result, it required collecting data for across time. So this is 6 days that it took here, and indeed there seem to be almost geometric straight lines in this data. So as you add data together that's disconnected in time, you have to be cognizant of what's going on. What I tried to present now is a result of a paper, and it's telling us about using these type of sensors, these type of satellite sensors, and also models, and how are they performing? It's important to understand, really how well do these things work. And so in this paper, there's discussion about using observation systems on the ground. So there are groups that are actually, they make the soil moisture measurements, in different areas, and spread out globally, actually, but not in an optimal way, but anyhow spread out globally. So what we can see, and then then they can compare these actual measurements to certain, pixels of these other instruments from the satellite-based observations. And so there's a list of them across the top. You can see, and maybe the ones that we've mentioned already, but plus some more. Well, here's the thing. Over here, so these are correlation coefficients, that how well the measured on the surface equals the observed from the satellite. These are correlation coefficients that they report. If we square these numbers, we get over here on the right hand side, we get a number of about 0.64, and on the left hand side we get a number of 0.36. So these R-squared values are really telling us what proportion of the variability that can be explained by the satellite instruments, how much of these in situ measurements can be explained, what proportion of the variance. So 36%, 64%. So this gives you a feel of the one of the aspects of the performance of these sensors. I move. We leave those satellite instruments behind and discuss the ERA5 land product. ERA5 is EU's state-of-the-art climate analysis, and it's being run continuously now. And what we talk about here, the ERA5 land model, it is taking atmospheric inputs and driving a land process model, so we can have better details about the land and the various processes that are going on. So the thing that this does, it takes observations from many types of observations on the planet, on the surface and land, at sea, through the atmosphere with radiosondes, but also with many constellations of satellite observations. This I mentioned that this is going on by this is basically headed by the European Center for Medium Range Weather Forecasting, the ECMWF. So this land model, we look at it, and it's seaming together space and time at relatively high resolutions. In space, that's about 9 kilometers, but it's doing this globally. And in time, you can get outputs monthly, but also hourly. So we can see diurnal variation in this with this possibility. So what I can show is an example here of some of this ERA5 land soil moisture, and we're looking at in layer 1, the surface part. And what I did is select a pixel. So we're looking at a system of 9 kilometer pixels, in our Finland, Sweden, Norway area. And I chose one pixel here, approximately in the middle of Sweden. And over here we see how the value of soil moisture at that one pixel is changing throughout the year. And you can see these various characters. These are episodes when we have precipitation, rain or snow, and then this relaxation period. All those things that Aura and Annalie mentioned, runoff, percolation, evaporation, evapotranspiration. These things are happening, and this causes the loss of the buildup in the water. The loss of the water in the soil. Okay, then next to try to be clear. So these are what is received by the ERA5 land from ERA5. So it gets total precipitation and then the energy and the wind sort of information, and what it's capable of doing. I show this to sort of give some details about the complexity of these and the the way to think about these models, they have a section that demonstrates the soil moisture here at different layers. What are the variables associated with snow? There are evaporation and runoff parameters. They're not really organized well on this chart, but anyhow they give insight to how this what are the nature of the variables that are needed to understand this process and model it. Okay, that's the end of that. But what we want to suggest is where theme 1 wants to be. Now you've seen in the backdrop, you've seen the different time space sort of locations on this chart. Where theme 1 wants to be is down here in this yellow, in this orange box. It's arguable that this is a concept of downscaling. We want higher resolution especially in space, but perhaps also in time. And basically there are lots of different possibilities, different types of data to take and to produce this type of result. But it takes maybe new ways of thinking, and that's what we look for in this in our challenge for this theme. I invite Annalie and Aura to return, and perhaps we can take questions if there are some in the from the audience. Our presentation was
super clear.
Was super clear. Okay. Any questions, please? Any questions, please? Any questions, please? Any questions, please?
How mature solutions would you expect or look for from the teams?
Annalie or Aura, please.
I think it's really difficult to tell because we don't know who will apply for these and what kind of interdisciplinary background they will have in each team. So depending on that, I think it's really difficult to sell. But
I think,
yeah.
If I may add, I think we welcome also the conceptual ideas of how to tackle this problem. So not needing to be able to give us the maps, daily maps of
for all of
2 meter,
Scandinavia.
2 meter resolution. So we can take them, but we don't expect that it's
so an idea of how these kind of maps could be developed, that would be sufficient.
And a pilot maybe or demonstration maybe a
demo
test
area. Yeah.
All right, thank you.
Someone has any other question that you want to ask? No? Yes? I think we have 5 more minutes before this team is over. So I just want to highlight that you can read more about this challenge in the UltraHack page. And if you are too shy to ask questions here, don't worry. You can also ask them later on in Slack. So we all gonna be there to answer your questions. And I put in our chat right now. So feel free to ask questions there and feel free to go read more about the team and the challenge in the UltraHack webpage and of course eventually apply. So yes, we have still 4 minutes. So
if we don't have any question, I'd just like to say that this theme 1 challenge is really important for the future sustainable forestry, both especially in time of climate change. when the systems are changing rapidly, and we might experience more drought and heavy rain events. So having that temporal variability in fine scale mapping will really help us with sustainable forestry in the future.
Yes, thank you so much. Thanks to our speakers and thanks to the team number 1 starting this webinar. So let me, and someone asked if it's possible to provide us these presentations, please. The presentations will later on be available on Slack, and also the recording of this session will be available in UltraHack page. So you will gonna be, of course, able to access to these presentations after this, so you can eventually ask questions later. Yes. Someone wants to add something, or can we move on to the team number 2?
Okay, thank you. I say that.
Thank you. Thank you to all our speakers for the team number 1. And now we are moving to the team number 2, change in species habitats, prevent damage caused by Sprucebock beetles. And yes, we will introduce the team number 2 and welcome to our speakers. And the stage is yours now.
Thank you. I believe I will begin. Let me just get my screen up and running. Right. You should now see a big screen stating Theme 2, changes in species habitats prevent damage caused by Sprucebock beetle. If this is what you see, all is good. If you can't, let me know. On a personal note, we all know what happened in the Olympics. Finland beat Sweden 4-3 in ice hockey in the overtime. So it is funny or nice that despite of that, Johan Fransson is still willing to cooperate with me. We all know how bitter we are when it comes to ice hockey. But I'm glad it was Finland who beat them this time. Now, my name is Markus Melin. I work in Luonnonvarakeskus Natural Resources Institute Finland, and I'll be telling you about the role of Sprucebark beetle as a pest. And this is actually very important for when it comes to Northern Europe. You all see it in the media that these big forest fires are ravaging and destroying habitats. Well, actually, when it comes to Central and Northern Europe, it is the Sprucebark beetle that is killing the forests and causing the damages. The fires are nothing compared to what the bark beetle does. That is why we are afraid of that species, and that is why we should be prepared. In his presentation, Johan will go through on how remote sensing can help us here, and I will go through the basics of this species and why we are afraid of it and what you should know about it in order to develop your winning application. I assume there will be a lot of time for question and discussion after the presentation, so without further ado, let's continue. As a first background introductory, life of a bark beetle. This is what we are talking about, the Sprucebark beetle. Nice small insect, and the larvae is the white one, and this is the immature one, the brown, and dark is the adult. That is the #1 insect pathogen in all of Europe, not just for Finland, not just for Sweden. When it comes to amount of hectares of forest killed or volume, how many cubic meters of forest it kills, this is the #1. The life cycle of this species in a nutshell, they start to breed in May. That depends on temperature. If it's very warm, it can happen in April. So the adults have been overwintering, and then when the spring comes, they will begin to breed. Males bore in trees under the bark, and then they shoot out pheromones, which attract females there for breeding. And this is what it looks like. They actually do these tiny holes. You can see where it has gone inside the tree. And there the breeding happens. If the breeding is successful, the female creates a gallery like this. It lays eggs, and then the eggs develop into larvae, which then will leave the tree and produce a new generation of beetles. The larvae hatch out in July. Again, if it's very warm, this can happen in late June. If it's very cold, it can happen in August. It all depends on temperature, which is why climate change is such a big factor here. These typically mature and overwinter either under the tree bark or they drop down to the ground. And then when the winter is over, they will begin the cycle again next year. That is a summary of how the beetle lives its life. And what is actually the damage? We will get to that in a minute. A couple of points about the warming. If the summer is very, very warm, the same adults can breed twice. First in April, May, and second time in June. If this happens, we will have a new brood of new beetles. Note number 2, if the late summer and autumn are very warm, the children, this sister brood, can also breed, and then we have a whole new generation. And that is, again, I bring this up because the climate change is such a huge factor here. If it's very warm, the amount of beetles will double very easily. If it's cold, they can't do anything. This is rare in Finland yet. Even if the newborns, the second generation happens, our winter is too cold for them to survive. But as we all know what is happening with our climate, we should be aware of these issues. What is the damage that the species actually causes? What does it do to the trees? Well, the damage is this. That is the gallery created by the female and the larval galleries. And what does this do to the tree? Well, if these galleries happen, wherever they happen, they cut off the flow of fluids. So stuff that the tree is producing in the needles that is supposed to go to the roots can't go to the roots. Then this is what happens. Starting from an individual cut into many, many cuts, and eventually that results in the death of the tree. The beetles also have a fungal species with them. They take to the tree to feed the larvae, and the fungal species also takes a role in weakening the tree and killing the tree. Imagine if your veins, your blood veins are being cut with these teeny tiny cuts. Your blood will stop flowing and you will die eventually. The dynamic is the same. When many cuts like this happen, the tree just can't flow the fluids that it needs to live. The damages, they don't happen just anywhere. The name is Sprucebark beetle, so it happens in spruce forest and also in mature and big trees. So they don't attack tiny trees because they are too big. They can't live under the thin bark of a tiny tree. In Finland, the damage is actually secondary by nature. By this I mean that the bark beetle alone cannot start to kill trees on a large scale. It is just not powerful enough yet, or our climate is too cold still for the beetle to do that. Something triggers the bark beetle damage or ignites it, and in Finland it is usually this. When there is a storm, big or small, the spruce trees are the first ones to go down because they can't stand wind very well. And now those trees that lie on the ground, they are weak. They can't defend themselves against the bark beetle. So the bark beetle will hunt and attack these trees. And after the primary damage, the wind damage, the beetles can breed in these trees. And then all of a sudden, they are abundant enough to kill healthy trees. And that is how the cycle begins and how it continues. So in Finland, we are always looking for where the wind damages may occur, because those are the places where the bark beetle damages are most likely to happen as well. In addition to storms, especially in Central Europe, drought is a very significant driver of beetle damages. If it's very dry, the trees are also very weak and they neither can't stand the attacks by the beetles. So something is happening in the climate or in the environment, and those are the triggering factors of a bark beetle epidemic, typically wind or drought. Now, this image is from Central Europe. So when I'm talking about large-scale tree death, this is what I mean. This is actually much more severe than a single fire. And if you again think about the fire, the dry trees are good for the fires to happen in. It is all linked to one another. How much damage has the species caused so far? I actually want to convince you that we are talking about a big issue here. So let's take a small table here. Here we have damage, how many millions of cubic meter of wood the beetle has killed or a storm has cut down. In 3 countries, 2017, this is what Ips typographus killed in Germany, Czech Republic and Austria, and this is what storms did. And 2018, the same story. Let's focus in here. In 2017, storms cut down some 7.5 million cubic meters of wood in Czech Republic. And do you remember what I just said about wind damages and where the beetles will breed? Well, when this much of wind damage was lying in the ground, the beetles were breeding in them and then the next year they were killing 20 million cubic meters of wood. So the chain of events was clear. First you had the huge storm, and then you had the huge bark beetle damages. In that year, Czech Republic cut down dead wood more than they did live wood for industrial needs, which kind of tells you about the scale. In general, regardless of what European country you go through, the bark beetle damages and their situation has become worse. Here is fresh data from a fresh paper. The amount of wood cut down because of bark beetle damages, millions of cubic meters in different countries starting from the 1980s up until 2017. So there's a huge jump in here, and 2018 and 2019 were still very high. So yeah, it's not really a small scale phenomena. Change the slide. Come on, here we go. Important points, and this is basically for you, the guys who are about to attack in the challenge and create your bid for the prize. What should we know about these species? Well, for risk management or being prepared, we should know the areas that are most susceptible to droughts, most susceptible to wind damage, and we should know something about the ongoing summer temperatures, because these will tell us about when the damage risk is very, very high. Remember, if it's a cold summer, nothing will happen. Even though wind will cut down trees, if it's cold, the beetles won't be able to do anything. But if it's very hot and very dry, the beetles will go mad. Few points for Finland. The sprucebark beetle will benefit from this warming that we are now experiencing, and range expansion is likely. Here are all the recorded damage cuttings due to bark beetle in Finland, 2012 to 2019. So you can really see where is the peak or the hotspot of all the bark beetle damages. In the future, we are expecting this border to rise up or go further up north. Wind is still in our country the predominant driver of bark beetle damage. So again, where do wind damages happen most often? Do they happen in big forest, in dense forest, or next to a open area such as a clear cut? Whatever you can dig about these issues will help you in determining what is the risk site for bark beetle damage to happen in. And I can't say this enough, bark beetles are winners of climate change. This is what has happened to Finland's mean annual temperature from the 1850 up until 2015, and this is what is predicted to happen depending on how much stuff we shoot up the atmosphere. These come from the Finnish Meteorological Institute. Yeah, with these points, I give the floor to Johan. I hope that you will now remember something about the bark beetle ecology and why does it matter so much for us up here. And do contact me for further questions. Find me in Twitter, find me in email. I have never used Slack, so probably you can't find me there, even though Francisca said so, but I'll try to learn how to use that one too. But now let's give the floor to Johan. Thank you.
Okay, thank you very much, Marcus, for this excellent introduction about the bark beetles' life cycle and the damage that they cause. I will continue this presentation with talking a little bit about early detection and risk assessment of forest stress from Sprucebock beetle attack using remote sensing. And first of all, I would like to acknowledge my colleagues Lang Ning, Henrik and Eva, who has helped me to prepare the slides. So let's continue. Marcus showed some pictures of infested forests, and here is another picture where you can see a greenish infested trees turning to reddish brown. If you are a forest manager or forest owner, it's a little bit important to keep track of the vegetation season and what Marcus also explained about the bark beetle's life cycle. On the upper part of this slide, you can see on the left-hand side greenish infested trees, and on the right-hand side this reddish brown dead trees. And they are developing throughout the vegetation season from April, May, where you can have the first swarming, depending on the weather conditions and the temperature. As Marcus pointed out. But before, I mean, the vegetation season start is actually important to start planning for the year's action and complete this planning until April. And when you have done this planning, you are a little bit prepared and can continue to take care of, hopefully, of the damage that the bark beetle will cause. In May, June, after swarming until hatching, the most effective damage control can be performed. And then it's very important as a forest manager, forest owner, that you transport all the timber out from the forest before the 1st of July. And then it could be eventually happen a second swarming. And this could happen in July and August, also depending on the weather conditions and so on. And then in the end of the vegetation season, you need to plan again ahead for the next season. So this timeline is a little bit it's nice to be aware of and also to have as a guideline for taking care of the damages throughout the vegetation season. Okay, so when what are the main questions using remote sensing? Could say the first question is what are the differences in the images between healthy and attacked forest? And regarding the differences, I refer to the spectral differences in the signal, in the satellite signals, for example. And the next question is when did the differences start to appear? And of course, we would like to have early warning system developed and try to find these differences between healthy and dead trees as early as possible, and how to detect the infestations precisely and efficiently. So those are some of the questions that need to be taken care of. Using remote sensing, Kendall explained a little bit about different wavelengths and so on. I refer to this slide to show you where we have the visible part, visible range in the spectrum, and this is between 380 and 850 nanometer. But we would like to see the bark beetles with the different sensors, preferable satellite sensors, before we can see the infestations with our own eyes. So therefore, we are investigating the domain of infrared, but also radar remote sensing in the domain of microwaves. So in the infrared, we have sensors that are sensitive to near infrared radiation, to short wave infrared, and to mid wave infrared, and also for long wave infrared radiation. So this domain is actually quite important to get familiar with, to utilize also to try to detect the Sprucebock beetles infestations before you can actually see them with your own eyes, to have this early warning system developed. So what kind of satellite data is possible to use? I just pointed out optical and radar here on this slide. For example, the Copernicus Sentinel-2 satellite data. We have 13 different spectral bands from the visible to the infrared, and a little bit of different resolutions here, 10, 20 and 60 meter resolutions, depending on which band or which wavelength the satellite is recording. So this is free of charge. We have other optical data sources, WorldView 3, for example, with a lot of bands, with high resolution, also high resolution data. For example, this short wave infrared resolution is 3.7 meters, so that is quite high resolution in this spectral domain. But this is not free of charge. This is satellite data that you have to pay for. Then we have, for example, radar satellites. Sentinel-1 is one of the satellites also within the Copernicus European program. and we have utilized they utilize C-band and 6 centimeter wavelength, so they are quite long wavelength compared to the visible and infrared nanometer wavelength. This could be downloaded and with a resolution down to 5 meter. Then another one is the Japanese ALOS-2 Pulsar 2 sensor with a little bit longer wavelength, down to 3 meter resolution. So this is just examples of satellites or satellite data that could be used to detect the bark beetles. But you need also field data, not only satellite data, in order to validate your models or your results. So this is just an example to show that we have some field data in the southern Sweden at the test site there. And on the right-hand side here, you can see the blue polygons that they are all spruce stands. And among these, within this area, we have marked in red and yellow, attacked and or infested and healthy trees or plots of trees. So this is important information to use for validation purposes. And also in this case, we have used the Pleiades data, optical data, also as a source with a half a meter resolution optical data to really try to find not infested areas. But this has to come together, of course, with field measurements. Some examples from the literature that could be usable for you to dig into further. We have already results from the 1960s concerning the mountain pine beetles, and it's more or less the same symptom, or I mean the same symptom as for the bark beetles. I mean the tree will eventually die when they are attacked with pine beetles. And there were some literature published in the 80s here, you can see, and also 2006 and 2009 from Volder. And it was not so easy actually to see these green attacks, as we call them. This is the very early attack when the trees are still green, but infested with bark beetles. So even though they were infested, it was not easy to use remote sensing to see the infestation. Also, despite that, the water stress at the leaf level was also very clear. So it's a really challenge to have this early detection. When it comes to Sprucebock beetles, we have some literature from 2013 to date, and in these papers we have they use drone data, multispectral, hyperspectral from hyperspectral cameras. Also optical radar satellite images has been tested and used with different resolutions. And we have one recent paper from Langning, who wrote as SLU, that developed a new index, new vegetation index that was quite nicely used for detection of Sprucebock beetles. And this index was known as NDRS index. We have other authors that also have been publishing paper about this topic. So what about some preliminary results using remote sensing? We have the visible domain, red edge, what we call it, and near infrared and shortwave infrared. Those are the bands that we record data from the satellite in, and we can follow throughout the vegetation season from April to November. The red line here is the attacked forest, and the blue line is the healthy one. And you can see it's a little bit of differences here in the visible bands between the attacked and healthy. And then you can investigate all kind of bands and see what kind of differences can you find. And here at the shortwave infrared, we have quite a gap between the attacked and healthy ones. So here it started to be quite of an interest to investigate this kind of wavelength, because they tell you a little bit about the water content in the trees or in the forest. Those bands can be turned into vegetation indices, and here we have a list of different vegetation indices. The most well-known, I think, is number 8 here, the Ndpi Index, that tell you a little bit about the greenish of the forest, the normalized difference vegetation index. So you can elaborate and try to get some different band combinations here and see if they could be used for early detection. But if the individual bands here or the wavelengths, if they don't work well, the vegetation index don't work well, you have to find out a new concept or new ideas about new vegetation index. And then you have to figure out what are the important bands here from the satellite and what are the necessary bands. So something to think about within this challenge. These 12 indices that I just showed you are shown here also in these diagrams. And you can follow, I mean, the attacked ones in red, and the blue one is the reference showing the healthy trees. So this is the kind of analysis that you could perform, I mean, to invent or to develop a new index and see how it will behave according to your infested forest or to the field data. Something a little bit about also the spread, the pattern, and to the upper left here you have a spruce, couple of spruce stands. That is the state in November 2018, and if you go to the lower left corner here of this slide, you can see the same area in July 2019, and you can see that on the edge here on the border to the left here there are a lot of trees that have been cut away, and that is the infested ones with bark beetles. And you can see also in the time series here on the right hand side picture going from beginning here in the upper left corner from April 2008 to the lower right corner in September 2019, how this stand here develop over time. You can see the red dots in or pixels in the edge of the stand, and they are eventually cut away by the forest manager. So by studying the time series, you can also see how this pattern will behave over time. So the real outcome of this challenge, the theme 2, that is to make it easy for a private forest owner or forest manager to be able to follow the development of their own forest or the forest that they take care of, and see if there are spots of infested or attacked forest that arise or spread. And this could be done by developing early warning indexes, as I mentioned, to find out the current state. But it could also be done with risk assessment or develop risk assessment tools, and that is to forecast the locations where the infestations are likely to happen in the future, and that is equal as important to be prepared for the changing climate in the future and so on. So for example, in this theme you can create, or where you are expected to create, a Sprucebock beetle prediction model to produce maps, and the map should display the current state. And in addition to the current state, we will also like to have these forecast maps showing the state in 5 years or maybe 25 years, for example, from now. And then, of course, you should use a lot of different data sources, and for example, tree species distribution data is important. The Sprucebock beetle only infest or attack spruce trees. So it's good to know where the spruce trees are located, for example. And then you can also, of course, utilize data from other sources, climate change forecast data of historical Sprucebock beetle locations, where you have wind-thrown forests, for example, and so on. And a lot of satellite data, hopefully both Sentinel-2 and maybe Sentinel-1 or radar observations are more than welcome to be used here in this theme. And last but not least, the weather data is of course important to incorporate in the analysis. So then the maps can then be validated and on historical in situ measurements, and the validation part is equally important to show that your model and your prediction model really work. So that was a little bit about the presentation and of theme 2. Thank you very much for listening. And then we go to questions and answers.
Okay, we have someone that has a question. You can open your mic and ask.
Yeah, thank you very much for a very interesting presentation. My name is Kai Suomela and I come from Ostrobotnia and regional mayor for a couple of more months, but I'm a forester, so that's why I'm especially interested in this. About 10 years ago, I visited Tatra Mountains and I couldn't believe my eyes, because the spruce forest was totally killed by the Sprucebock beetle. There was thousands and thousands of hectares because they told they had a storm and they left all the wood in the forest. There was a discussion that it's natural. Yes, at the next summer. But this summer I was on a boat trip from Mariefred to Birka, and just watching from the boat, there was thousands and thousands of hectares of this spruce forest in Sweden. And we are talking about the level of Stockholm, which means we are going to have this in Finland, I guess, pretty soon in a big scale also. And my question is, can you predict in early stage which trees are hit by the beetle so you could cut down them fast enough? Because when you see the damage and the tree is dead, it's too late. You only harvest the forest, but the insect has already fled and doing their business somewhere else. I mean, this is a big economical question. Can you predict in good time and cut down before they spread to the next forest?
Yeah, I could say just a few words here. I pointed out the risk assessment modeling part, and doing this risk assessment modeling, that is the aim and the purpose for doing this is to point out to the areas that are likely to be infested. I mean, for example, if you use then digital terrain models, maybe you are more likely that it's more drought in the uphill and downhill and so on, and then try to modeling this together with soil moisture maps and so on and so on. So I mean, I think it's possible, but to a certain extent, to point out this area better than we can do today. What do you say, Marcus?
Yeah, a couple of points. One, Sweden and Finland, we have our forest legislation which mandates you to remove damaged trees. So if you have a storm in your forest, you have to go and get a majority of the wood out of the forest so that the beetles can't breed in it. And second, to detect the individual trees, the problem is that even though we would have the best satellites ever, our summers tend to have a lot of clouds in the sky, which means that the satellites can't see the trees. So the theory is very strong that yes, you can detect the early stress. But I would like to also highlight what Johan said about the understanding the risk areas. If you know where drought is most likely to hit the trees, if you know where wind is most likely to damage them, those are the sites to focus on.
Yeah.
Here it is a very good thing that we still have a short summer and cold autumn and very cold winter. So yeah, it's better for us in Finland rather than down south in Sweden. Big difference.
Yes, thank you so much. And please, if you have some questions that I see in the chat that's been answered, please keep putting in the chat because you might not have time to answer all the questions in this live Q&A, unfortunately. Yeah, we're closing the theme number 2, and now we are moving on to the theme number 3, how to reduce damage to the forest ground caused by forest machines. So, theme number 3, the stage is yours.
Thank you, thank you. I will open also my all possible connections, so wait a second. Hopefully you can see now the presentation. And okay, so welcome to here the theme 3. The topic is how to reduce ground damage from forest machines. My name is Kari Väätänen. I come from Luke, from Finnish Forest Research Institute, and my colleagues Dag Fjeld, Jari Ilomäki, and Harri Lindemann are actually the brains in this team 3, and I'm the presenting duty. The guys are Jari and Harri are in the forest, and Dag seemed to be here. I thought that he will be in lectures, but we made a deal that probably this is also that Finns again won this competition, so I'm responsible then. So, Team 3, how to reduce ground damage by forest machines. What we expect you to do, this is an example, to build up a map-based demo application which presents weekly trafficability with, let's say, 2 weeks forecast. Not an easy task. To take one word from there, trafficability. What does it mean? It's the ability of terrain to support the passage of vehicles. And in this case, in forest-related operations, means heavy logging machinery. So we expect for you to use data from multiple sources, data fusion, science. This is important to understand the basics and the phenomena. I will present some of those. And to give up the latest digital tricks. This is a basic problem in Finnish and Swedish operations, harvesting operations. As you can see, it's a huge variation in seasonal production. Harvesting removals will change throughout the year, and you can see the trend between the years. So it will heavily stressed on wintertime loggings, and during summertime, the loggings are less than a half from the winter loggings. You can see the time span from 2015 up to this stage. Seem to be also in Sweden, so it's heavily stressed on winter time. Many things are influencing on that. If we take 1 year from there, 2017, here you can see that more clearer that loggings are stressed on winter time. It's big reason for that is that wintertime there are more accessible sites. Due to that, there's frost on the ground, there's snow on the ground, and we have now snow quite a lot, at least here where I'm positioned in eastern part of Finland. So we have better and more options from the stand site reserve sites available for winter loggings. It's stressed therefore. Another thing is also that we are counting on quite much on thinnings, and when we are operating on thinnings in for example in spruce dominated ones, it's more sensitive to operate during winter time. Here you can see also the production of wood-based products, so it stays more or less the even level. So you can see the difference, the harvesting and the production. Therefore, it should be quite much winter stressed, and this extra timber volume goes to the buffers, to the terminals, and to the roadside storages. And during this low season harvesting, the gap will be fulfilled partly also from these storages. Here you can see now the harvesting seasons, high seasons, lower seasons. So we expect to get more even distributed timber harvesting. That would lower the harvesting cost, logistic costs, and we expect to get also less soil damage. What we need? We need decision support map applications. Why? We could get more possibilities. We could get better methods for production scheduling. We have a certain amount of site reserve where from we can detect better the sites which would be more suitable for summer loggings or for loggings during a non-frost period. So we could get more evenly distributed wood harvesting throughout the year. Another thing, we could, with this information, more improved prediction and precision, we could select better the equipment for the operations. And inside the harvesting site, we could make better actions. So how we should do it. Results, less soil damage. So here you can see soil damage. There's quite the first case scenario. We are at the wrong time in this site with the wrong equipment and also most probably it's wrong placement of forwarding trail. And then again, we should not let this happen. When it starts to be like this, we should quit the logging and find the right time to come back. So this is unacceptable. How to improve? Let's go to the basics and see the phenomena in behind. So we are talking about bearing capacity. As a terminology, that is the ability of forest floor to resist vertical loading of the forest machine. And it has a strong effect on trafficability. The correlation is basically equal in even lands and forest sites. Bearing capacity is highly dependent on the soil type, gravel, sand, silt, clay, or peat, differently affecting to the bearing capacity. And then when we add the soil moisture, I have to say that this theme 1 presentation was really good, and this soil moisture has a big influence on the bearing capacity. Has a different kind of impact on different soil types. And then we have reinforcing elements, tree root system, logging residues, and during winter time we expect to have a ground frost, or if we don't have ground frost enough, we expect to have enough depth snow cover. So with these figures, you can get our overall understanding of what we expect to have for ground bearing aspects during summertime and during winter time. A bit more deeper into the different issues and aspects which influence on soil bearing capacity. Soil moisture. The more moisture the soil is, there's a less bearing capacity on the soil. It's more or less this kind of concave function influencing on that. But when we take the soil type into account and the soil moisture, you can see here a bit of a differences between different soil types. When we are on the coarse sites, coarse grained sites, for example, sand or grain sites, there's not a big difference or whether it's a dry or wet soil. But then when we continue to go to the more fine grain sites, the difference will increase. As you can see in clay sites, the bearing capacity might drop drastically. In organic sites like peat sites, the dry conditions are already quite in a low level, so there has to be other bearing reinforcing elements to take into account. This is one Swedish example of this different kind of classifications for different site soil classes: gravel sand, fine silt, clay sand with different moisture contents. And there are also different kind of bearing capacity classes, with one example of the kind of a rough distribution for 3 different capacity classes. What about then bearing capacity, how it relates to the reinforcing elements from the stand density? The more dense the stand is, the better root map coverage is there, which gives the reinforcing element. Moreover, you can get more locking residues to the harvesting the paths where the machines are moving along. If you are on wet soils or organic soils, that improvement is more evident. You need that in order to improve the soil bearing capacity. Effect of weather. So when we talking about the whole year round, so we need to take different conditions, weather conditions into account. And for example, in temperature, winter, we expect to have a cold period. So when there is a freezing season, we expect to get frost on the ground. Then again, if we get the snow, snow is insulation, so it might be like now in eastern Finland, we have a really low amount of frost on the ground due to the quite a big snow depth and early snow. Non-frost period, it's important also to see and understand that what's the importance of rainfall and the precipitation, and then again combination of temperature and precipitation. That how quick it recovers, soil will recover after rain periods. So we Finns are relying on winter harvesting on wet soils, and we expect to get then ground frost over 20 centimeters or snow cover more than 40 centimeters. Those are from Ehronheimo 91 for peatland forests. And nowadays we have good map presentations for ground frost, and there's ground truth fixed positions for measuring places in different places in Finland. Same is also for snow cover. And we have a history data also for both data, and we can see the seasonal this climate change impact on shortening periods of frost periods. So solutions for the seasonal scheduling. We have had traditional classifications, and we have I have to say that this is a really good approach that what we have used now, that we have classes from worst to best regarding on soil moisture and trafficability, starting from spring thaw in the worst case, fall rain, getting better typical summer drought. We have more options and possibilities to operate in more different kind of site conditions, and then we have snow and frost. We expect to go more and more fully digital solutions, combining soil and moisture maps, and including weather daily, soil water modeling, and whatever. It's up to you to solve this. What are the available data for solving the problem? I've opened something there, but these are the main themes which you should consider. The soil type. We have ground properties from Finland and different scales and resolution. Also in Sweden. We have a soil moisture, groundwater level, precipitation data, and we can get some information from digital terrain models from DITSEs from peatlands. Forest data is important, vegetation and impact of that. Water accumulation means that how the rainfall will eventually accumulate on lowest level points of the terrain. You can utilize then depth water maps and terrain wetness indexes, for example. When we go closer to the winter, we need to know what's the impact of soil frost and snow cover. In Finland, we have data from these, and you can combine the data from historical data and the conditions together, how it changes. These are the ones, but then I will show quickly the recent development of maps in this trafficability environment. We have had in Finland static trafficability maps, as you can see here in this picture. Different colors represent different kind of seasons when it's possible to operate, but they are static. Like in Team 1, there was well presented this. And then we have depth water maps starting first from Sweden and coming to Finland. In Sweden, they have used quite a long time already during harvesting, which helps in finding the best ways to where to transport the timber and avoid the wet areas. And trafficability predicts. That has been a development in Finland, in Luke and the University of Turku. And that was already presented in Aura's presentation. Harvester season is the latest development and which is available in at the moment in the net, and you can go to see and get an understanding what are the latest updations to take into account the dynamic approaches to this estimations for trafficability. And it's a good example here that trafficability can be explained not directly as values, but it can be in a level of bad or good, and once you get the understanding how it varies in different places and what does it mean, it helps anyway to operate. In Sweden, SMHI is presenting applications for the forest operators and contractors to see that how the moisture is changing on the sites, forests, forest soils, and for example, creative optimization is developing different kind of applications like timber trail to operate with the low impact operations on the forest, in the forest. Important now is how to make use of new satellite data. There's a lot of satellite data available, like there was in the earlier presentation came up, and important is to utilize now this data and combine and fuse this data to all the available traditional data, open data. We would like to know the future, at least the close future, that how it will change, but how accurate is the weather forecasts, and will they get more accurate? This is also important, and we expect that we can estimate better the future. So theme 3, start your motors, and I will show now what to do. So example, this is example. It's a good example, I say. Create a map-based demo application which present weekly trafficability with forecast function. And the motivation is that improves harvest scheduling and that will reduce ground damage. How to solve it? Knowing your basics. So soil bearing capacity and how it is affected to soil bearing capacity. Different soil types, how they are affecting the soil bearing capacity. We have these maps available. How the soil moisture is impacting the soil bearing capacity. How the freezing, thawing periods, drying cycles influence on the trafficability, and how bearing capacity can be reinforced. An important issue is also to get an understanding that how different equipment types, harvesting equipment types affect on the operation, on the damages, on rutting. And then find and get useful data sources, and there's a lot of open data sources available. Soil and forest data, this is like a basic data to be used. Then frost depth, snow data, there's a historical data available. Water accumulation data, so these maps, depth water maps and terrain wetness index maps are important to use. And then precipitation data, soil moisture data, and important of all of these is to utilize satellite data sources. Okay, be creative, envision. We expect to combine sources, traditional and new satellite data sources. You can work wide or focus on deep. It's up to you. It's maybe more easier to focus on smaller areas and concentrate on working applications. That data into applications should be considered that it's easy updatable, and map applications should be easy to improve. So the important is to put together a running demo which visualizes in the map the trafficability of ground bearing year or index in function of time, and which enables for better harvesting planning. And there are plus points if you can simultaneously visualize some important variables, elements, drivers like precipitation, temperature, soil moisture while running the demo application. This is our mentoring team, Dag Fjelt from Sweden, SLU, Jari Ala-Ilomäki, Excellence in Terrain Trafficability, Harri Lindeman for Excellence Soft Soil Logging Solutions, and I will be also available for giving more support for you when you are starting to solve this problem in Team 3. Thank you. Any questions for me and for Dag? I expect Dag is also now here.
Hey, Kari, lovely presentation.
Sorry, I was just about to say thank you so much for the presentation, and people can of course put the questions in the chat if they are too shy to talk, and read more on the description page about the challenge and the team number 3.
Yes.
We have now like 5 minutes for questions, and also if team number 3 wants to add some information, it's the right time to do it if there is no questions related to this. But usually the questions show up later. I think people are still processing the information.
Question to Kari from Dag.
Shoot it.
For fixing this theme 3, what would a good team look like? What sort of people should we have on the team to fix this sort of thing?
Yes. The best would be that there's a coder, there's a person who knows about the forestry basics of operations, but it's not necessary because there's a good group of mentors who could help building this problem and giving the aid on this. And then it's good to know that how to use data, this kind of spatial data. It's a big data in a way, and it's if somebody has used already this kind of data and combined different kind of data sources is I think is essential, or it helps a lot. So I think these things are at least in my mind. Can you add, Doug, something?
Well, I see it says demo an app. So we need somebody that can build a simple app, right?
Yeah. So coder, programmer, let's say.
Yeah, a coder. Okay, good.
Yeah,
thank you.
sorry, my English.
So some foresters and some programmers.
Yeah.
Good, thank you.
I can just mention a comment from theme 1. As you see, theme 1 and theme 3 are both aiming to decrease the problems when trafficking on forest soils for sustainability. So while theme 3 focus more broadly, taking into account also ground properties and the forest properties, theme 1 only focus on the soil moisture and how to combine the temporal variability from satellite to the high spatial variability maps out there.
Yes. Agree.
With the hope of sometime in the future that will feed into the models developed by theme 3.
Yes.
Yep.
Yes, great, great. Since we have no questions at the moment, we will be moving to the last theme of today, theme number 4, and after that we also have a platform introduction. But I would like to invite theme number 4 to take the stage with the new digital concepts for the forest value chain. Is theme number 4 ready to start?
Yes, here I am.
Okay, great. So the stage is yours.
Okay. Hello, everyone. My name is Ville Kankanhuhta. I come from the Natural Resources Institute, Finland, and I'm working there as a researcher for silvicultural service development and research, software development, information systems, quality management of silvicultural services, etc. And now I will make sure, are you able to see my shared PowerPoint?
Yes.
Very good, very good. And it's great to see also Jari here. We form the team of mentors for this team 4, which has a fairly great variety of different kind of topics. And let's go to the business through the technologies we recommend you to use. So the first one, of course, is the Earth observation satellite images, change detection applications derived from those images, also positioning systems, global navigation satellite systems, etc., etc. I won't read all the technologies through, but you may figure out those as I will go through the different examples of topics here. And considering the examples, here is the summary of those, maybe a little in small font, but you are able to see these ones also at the UltraHacks internet site. And now I won't read these through, but I will tell details about every example here a little more. So considering possible applications and your interests about virtual and augmented reality. So the challenge is planning and demonstrating the visual landscape effects of forest services and operations for forest owners. So there will be, for example, timber harvest, final cuttings, thinnings, etc. Maybe also some silvicultural work. And the approach would be what you could utilize our satellite images, forest and nature data, open data, what there is, and also other data sources which are available. And the need here are for new tools for marketing of forest services, for forest owners, and maybe also demonstrating the visual effects for stakeholders there. And potential benefits: better service quality, increased cost efficiency then of operations and the service production there. And as we go further, one topic is data mining tools for better prediction of timber demand and prices in the future. So the one approach could be what kind of data sources you could use. You could use cutting intention declarations from Finnish Forest Center, for example, satellite data, maybe change detection there, market data of raw wood from the statistical authorities. And the need for these kind of solutions. First, the better prediction of the state of timber markets, new tools for forest resource management services for service providers, and then maybe also new tools for setting local prices for services and timber trade. And in general, the benefits will be the better decision support for the different stakeholders there. Then, as we go further, this challenge is kind of it has two parts. First, the novel data management, data fusion and transfer concepts, and kind of platform concept for that, since there are several forest data repositories existing by different forest service providers and organizations. And also there is, for example, there are satellite images you are able to obtain there, and also other remote sensing data. And the approach would be to create a platform for data management, data fusion, and sharing the data through appropriate interfaces there. And here you should consider maintaining the different temporal snapshots from the data. So there should be different data layers then which you may access and choose according to your needs and also according to the client need. And what we have found out, the need is for better management, archiving, combining, and also producing new data grid layers without losing the original data. And the potential benefit here would be availability of most current and good quality data for the committed stakeholders or shareholders. And especially this will be used for more knowledge intensive forest property management services. And then the next part, or which belongs to this one, so there are actually two slides, is that maybe you also have to propose a business case or business cases how this kind of service could be financed and maintained. So as big different organizations are maintaining these data repositories and different parties have paid for the fieldwork, which is there, which is stored there. There is a challenge that maybe not all the stakeholders are willing to share their data for free, because the fieldwork especially is fairly expensive. And then if in your team there is an expert for systems analysis, maybe knowing game theory, etc., negotiation techniques, juridics, legislation. So there should be a concept and leverages for negotiations for shareholders, how to finance the maintenance of this kind of data management platform. So at least for the case for Finland, we have experienced that the lawyers considered that this would be too direct subsidy for the business here, and the official governmental parties organizations, they were not allowed to finance at least partly this infrastructure. So the need also for this case would be the business case is applying several disciplines in order to provide a viable solution here. And really the availability of the data for the use of several different stakeholders, there would be a huge advantage of this. Okay, this was one idea area, concept area. Then as we go forwards, there will be one idea of crowdsourcing solutions for private forest road condition and trafficability warnings for the heavy transport and machinery of forestry. Maybe also some dynamic satellite image layers or weather forecast information there. But also what we have considered that crowdsourced ground truth or observation from lower forest road network and forest areas could be needed there to maintain the database also. And of course also here there would be a need for an incentive for stakeholders to update the road status by crowdsourcing. And examples why this would be useful, what is the need? This is for the forest machine and logging truck operators or the supervisors who are not aware of the broken bridges, ditch drums, also different trafficability issues there near logging sites, etc. And well, this considering the potential benefits of this kind of application, it would come from the savings of labor time waiting for transportation resources, and then there would be savings for fuel, for example, because you don't have to travel around those obstacles through different roads, different routes, for example. So that was one concept area or idea. And then next one, next idea would be for fleet and productivity management of forest machines for cost efficiency work quality and agility of operations through new technology at fleet and machine level. And the approach could utilize both machine sensors, high accuracy positioning systems like Galileo, real-time kinematic positioning, machine data, also maybe Earth observation data there, and what we would expect and what is the need is the optimization of productivity of both machines and then fleets there, and more precise information for the managing of the harvest and silvicultural operations is needed. And in the future, we hope that novel and information-intensive forest operations concepts with added value will arise. Okay, then next one will be the precision forestry, precision forest regeneration planning, and there the challenge is that agile forest operations have to be developed in order to be able to flexibly select best fitting soil preparation method, tree species and regeneration routines for microsites within a stand. And approach could be tool development or data product map layer development for planning, implementing and controlling operations for microsites. And these could utilize soil and site type information, open forest and geological data, and earth observation data. And this would have also linkage for terrain wet indices, depth water maps, etc. in the theme number 1, for example. So the applications for forest regeneration could also we could really use those new maps, which will be provided, or we could use those later on, which are now produced and developed in theme number 1. Then considering the needs, what there is. So concepts of precision regeneration are potential solutions for mitigation of climate change and increasing resilience of forests through increasing the mixture of different tree species there, for example. So there would be appropriate tree species for microsites and not such a big risk then for example, storm, drought, bark beetle damages, maybe also against root and bud rot, for example, and other insect diseases or pests, their damages. And why do we use these decision support maps? At the moment, in the Nordic countries, for example, the workforce for forest regeneration, it's fairly low educated there, and their skills also may be a little low in the beginning, and there would be need for applications which use these forest maps, which show which tree species, which soil preparation method, which regeneration method there would fit best for those sites. And really the proper selection of tree species and best methods fitting for the microsites, they are important, and also there are aspects considering afterwards checking the quality of the implementation of forest regeneration work there afterwards. Okay, so that concept was for forest regeneration, planning and implementation. And then considering young stand management, there are also needs for a reliable assessment of the need for young stand management, and maybe also for a prediction for labor time consumption, although that may require certain time consumption formulas for you, or other private data of the labor consumption in older areas. And the great benefit for developing these tools would be that the supervisors for forest workers, they would not have to visit these young stands to evaluate the need for young stand management, and also the costs of young stand management to set right price tag for the forest service there. And the approach could be, you could use for these data products or decision support maps, open forest and soil data, vegetation indices calculated from Earth observation sensors, as there were examples at the presentation of theme number 2. And then also other data, maybe private data of time consumption, of the behavior of brush source, or other data sources. There could be more. So I could give some example of these data sources, maybe if you are interested about this topic. And the need, for example, in southern Finland, more than half of young stands are of poor quality. And there is also a great area of neglected stands where the young stand management operations haven't been carried out. And really the predictive tools are missing, and really the, let's say, cost efficient ones. And one solution could be the satellite image data, which could be fairly, let's say, of a moderate price, not such a high price there. And potential benefits there, several information intensive services for forest owners for young stand management could be developed according to these results. Okay, and then further, still a couple of these ideas, topics, enhancing biodiversity through better planning of retention trees, deciduous trees, which could be left for the stand after harvest operations to produce more decaying wood debris there. And this would be important for both rare insects and fungal species, conkers, for example, living on dead wood. And planning officers and forest harvest operators, the implementations of the operations could be planned more thoroughly if they could have a tool for planning these retention trees. And the tool, for example, for the identification of deciduous retention tree groups of birch, aspen, etc. Maybe also seed trees there, and buffer zones around the certain water areas, this kind of tool could be used there. And you could use satellite images there, open forest and nature data, crown height models, etc. And the need. At the moment, the retention tree continuum with the different tree species, sizes and degrees of decay has to be increased in the context of forest operations there. So the need would be that, and the benefits would be better tools, improved operations, and through this better ecosystem services and compliance of, for example, forest certification rules, what there is. Okay. And then 2 more to go. The next tool concept or idea would be natural harvestable forest product finder development. For example, a mobile phone tool for prediction of ripening and locations of different berry species, mushrooms, etc. And there have been some tryouts, but real breakthroughs for entry of this kind of software tool for the market. It really hasn't yet happened. And the approach for you could be a prediction tool for the locations and ripening of the berries and mushrooms, which utilizes open site and stand information, open weather data for the phenology or ripening of the berries, and also satellite imagery and the map layers from there, for example, for certain vegetation types. And these could be used both by amateur berry pickers by everyman's right, or then professional ones to find more berries, mushrooms, etc. And the potential benefits would be that the nature products would be utilized better, because there's a huge amount of these products left in the forest every summer, and maybe through this better nature products business and also better offer of these products for the market. Okay, so that was one example of the berry pickers. And then the last concept here, navigation for forestry and recreational services. So the challenge here is that for difficult terrains, dense stands with bushes, poor route planning easily ruins the outdoor experience, either by foot, mountain bike, or skis, or for professional workers they're moving around in the forest. And navigation tool for walking or riding in forest, which takes account the most current estimates of trafficability of the areas, using open forest and topographical data, and also satellite observations and satellite positioning, and for example, certain vegetation indexes could be also used here to predict how easily the terrain would be approached and wandered around. And tools for this kind of route planning and maybe also orienteering in the context of forest work, etc., hunting, recreational activities, etc., they haven't yet been adapted for wide use, so there could be also consumer markets for this product. And really potential benefits is of moving in the woods, better nature and recreational services, etc. Okay, So thank you very much for your interest so far, and maybe we will have time for couple of questions. Here is the Slack address, and maybe I will give the floor, for example, for you, Fran, please.
Yes, thanks for the presentation. Okay. And someone has any questions regarding to this theme? I see that the questions usually. Sorry.
Just one question. You had very many interesting challenge ideas. So any of them can be approached and produced a solution. And if that's correct, and what kind of solutions should they? On what level they should be? Should they be strictly functional, or could they be more conceptual, or what kind of solutions are you looking for?
I think that the most important thing is that we remember our general theme here, that will the solution proposed be more efficient and competitive than, for example, existing approaches through exploiting space data, what there was in the beginning. And then as that is considered, then comes the innovativeness of new kind of approach concept, and then it really, I admit that this, as this theme 4 is, because it's of getting you of thinking and trying to find out new idea solutions for these challenges. The judges then for this hackathon, they have to consider what there has been happening in that field, and then so it really depends. But so in every case, you don't have to have a real working demo. So concept may be enough. For example, that data fusion platform, that could be really a huge effort to make, for example. But then there are similar kind of approaches or solutions. What there was for other themes, that there would be a kind of thematic map which could be used for decision support there, etc. So it really little depends how it goes, but I will try to help you through if you are interested of certain topic and consider that one. But also, of course, you have to remember that these topics are a little interconnected also to the, for example, themes number 1, 2, 3, etc. So it little depends, but I will try to do my best, and I hope that I will get also help for you for dialogue and reflection and discussion of for the help for the hackers.
Yes, thanks for the questions and thanks for the presentation. This is the last theme for the hackathon, but now we will have the introduction to the platform, and it's the last topic for tonight, for today, I'm sorry. And after that, we will go through the prices and the next step reminders on BiUltraHack. But for now, we'll have the platform introduction, and I will give the stage now.
Thank you. So this is Renne Terkuja from VTT, and when Fran mentioned platform, it's in this case the Forestry Thematic Exploitation platform. So I will let you know what it is and how it relates to your options in in this innovation challenge. So let's look at a few slides. So basically, Forestry is an online solution for forest analysis in the wide sense, based on satellite data. So this is operated by VTT. It's offered to users via subscriptions. This has been developed in a European Space Agency project over a few last years, and it's been developed towards a platform that operates on market terms and hopefully in the near future also with third-party services as an extended offering. The key platform features include, of course, satellite data that is available on the platform. So all the Copernicus Sentinel-1, Sentinel-2, and many other data sets are there directly in the online environment to be ready to be used. The users can also upload other data sets, and any data can be processed on the platform. Also in parallel if there's like massive processing needs. There's a set of readily available data processing services. Some of them are open source and can be used in learning how to develop your own services. So that, I suppose, could be a key feature for any innovation challenge participants. So the platform features an online environment for developing new data processing services, and it all happens online on the platform. Also available the sharing features help to collaborate on the platform, so you can work together on a service that is still being developed. There's also an API interface for arranging external access to any development you have made on the platform. One thing to mention is that everything that you do on the platform is private to you unless you decide to share it, open it up to other people. As a platform, we are hosted on an environment called Creodias that arranges us the satellite data and the processing capabilities, and we are making then other more advanced features on the top of the Creodias platform, including the development capabilities. And there's a number of third-party services, and this sector we want to increase with new third-party services. This is what the thing looks like. On the left is the website where you can find all the information on the platform. On the right is the actual platform that you can access with user accounts. So how does this relate to this innovation challenge? We are making the platform available for the participants as an optional tool in developing your solutions, in particular when those solutions would involve satellite data, but it could be used with any other data as well. The day after tomorrow, 17th February, 2 p.m. Finnish time, we will have an introductory training on the use of the platform, and over the course of the time period until the hackathon, we will be providing user support on Slack and separately as well. You can already now, if you like, sign up for a free trial user account via ftep.com. The user accounts are managed via the ESA Earth Observation sign-in system. So that is actually the place where you get the platform and then, the user account, and then you can access the platform with it. Then all the teams that will get inducted for the Innovation Challenge, they will receive 1 month free of charge access to FTEP. That will cover their participant up until the hackathon. And then we will be supporting the winning solutions, the rewarded solutions after the hackathon, so that the continuity would be facilitated after the event. Then I will go through a few of the platform features. So the processing services and tools on the platform include a few thematic processing services, including, for example, a vegetation index calculation that has been mentioned here a few times and could be of interest. Land cover mapping, forest change mapping. There's a simple open source tools that can be used as is or as basis for further development. There's some supporting processing services for example, Sentinel-1 stacking, masking, mosaicing, radiometric corrections. And then there's a few interactive applications that can be used on the platform as well, such as QGIS that could be useful for many. The data on the platform. So there's Sentinel-1 and Sentinel-2 globally with the full archive available, as well as Sentinel-3. With regard to Landsat data, there's the so-called ESA archive of Landsat 5, 7, and 8. So these data are directly available via the platform interface. For service developers, there is also access via special arrangement during the service development for a number of other data, including these Copernicus service data. There's Copernicus land monitoring service, etc. There's also digital elevation model data available, and a few others. And as mentioned, external data can be uploaded to the platform. Service development interface on the platform is fully web-based. Internally, it's based on Docker and Linux, and understanding some of Docker and some of Linux will be helpful, but not too necessary, not in detail needed, because your actual implementation can be in any programming language that you are familiar with, and we will show you and help you in putting that in the context in this development interface. So the developer will be defining the processing logic and what input parameters the service will take in. Any libraries, software libraries that are available in Linux are basically available, such as Orphea Toolbox, GDAL, etc. There's no local software installations needed, and templates are available for this. But this is basically what we will go through in the technical webinar on the 17th, as is also the application programming interfaces for arranging external access. So there's REST API that can be used to make authenticated use of resources on the FTEP, including services that you have created yourself. We newly also have a Python library for making this REST API access easier from Python scripts that are hosted externally. So I suppose in many cases you might be thinking of a solution where your implementation is hosted externally, but you could making access to the capabilities of FTEP via an API. So please be welcome to join the follow-up webinar. There's a link available on the website. If you look just under the information for today's webinar, we will be introducing the platform in a bit more detail and demonstrating how it actually works and how you can work with data, how you can upload your own data, and essentially then how to develop any your own processing services and how to work with the API. I'm Renne Tergujev, and my colleagues Jukka Miettinen and Lauri Seitsonen will be available. They're probably not in Slack yet, but you can contact us via Slack. So we'll be glad to help you. And that's it, basically what I was meaning to say today. And I'm open to any questions at this point. And if not today, then please join on Thursday. Thank you.
Thank you so much. Is there any questions regarding to the Forestry platform? And please, I put here the link to sign up for the call happening on Thursday. And it will be sent also to all the emails of the participants here, so you don't need to worry. But yeah, no questions so far. And as mentioned before, if you have questions after this, you can always go present them on Slack. We will be there answering you, and all the mentors will be joining there pretty soon. Yes, so we will then move on with the last thing. I hope my slides are able to share now. And before we close the meeting, I want to say thanks to Rene for the platform presentation. And I think we will see again on Thursday, so we will get more insights and the overview about the platform itself and how the participants can use that throughout the hackathon also to boost their their creativity and also their deliverables for this hackathon. I would like now to jump into the last part of this webinar, that is about the prices and what you can get for taking part of this amazing hackathon. So let's go to the prices. The 3 best proposals across all of the teams will be awarded with the cash prize, also with 1-hour consultation from ESSA Business Incubation Center Finland for the application center process. Also, you have the possibility to enter the new Space Economy program of Business Finland, introduction to the regional startup community, not only in Finland, but also in Umeå. Did I pronounce correctly? In Sweden. And also the possibility on site tours with partners. The total price too for this hackathon is 10,500 euros, which is a huge investment in talents happening during this hackathon. The next step reminders. The registration happens until 10 of March, 11:59. On 11 March, we will select the teams and we will announce. Each member of the selected team will receive a confirmation email. And you just need to follow the instructions to confirm your participation, and then we will start the onboarding process. We want to thank all the partners and sponsors that make this possible. Without them, this webinar and this hackathon wouldn't be possible. And don't forget also to join the Slack and read more about the challenge in our Ultra Hack page. It was a pleasure to have you all here, and these 2 hours and 30 minutes have been a boost, not only for me, but I believe for everyone here about what's coming next month from 18 to 20 of March. If you have any questions, feel free to ask. And Ella, someone would like to say some closing words? No, but can you all hear me, right?
Yes.
Okay. Yes, that's great. So we will be closing this hackathon, and I would like to to all of you scan this code that goes straight to our Slack, and also to read more about the challenge in our webpage and be present in the platform webinar happening this Thursday. It's been a pleasure having you all here, and I'm so excited actually for next month to come that we will have our hackathon. Hella, do you have some closing words that you'd like to say?
Hi all, thanks Fran, and thank you so much all the speakers, partners and sponsors for making this happen. And of course all the participants online.
Thank you.
Thank you so much. All the participants, as I mentioned, will get by tomorrow morning the link for the attending to the webinar happening on Thursday. So keep an eye on your email, and thank you so much. We will be closing this meeting in a couple seconds. It was a pleasure. Thanks to our amazing speakers for the work of today. And thanks everyone being present here. I hope seeing you next month in the hackathon.
Thank you.
Thank you, Fran.
Thank you.
Thank you.
Thank you.
Thank you.